Oh my goodness, it is already Friday. Friday! Woohoo! How did that happen? Well, you know what they say, time flies when you're doing math. Time is flying by. We are already May 21st. Are you kidding me? Are you kidding me? How did that happen? You know what? We got this Friday and next Friday and one more. That's all we get. That's all we get this year. Feeling cheated. I don't know about you guys. You guys took so long to get here. All right. Anyway, uh, May 21st is actually the birthday of this guy named Charles Lindbergh. Does anybody out there know who that guy was? You know what the spirit of St. Louis was? Yeah, if you get to go to Washington, D.C. and go to the Air and Space Museum, there's a little plane, a plane that would fit in your bedroom called the Spirit of St. Louis. And that's the plane that Charles Lindbergh flew across the Atlantic Ocean. He was the first person to fly across the Atlantic Ocean. I think he left like New Jersey and flew. Yeah, the place didn't go that fast back then, so he had to fight. He was trying to do his best to not fall asleep, right? Yeah, they made a movie of it. I think it's called The Spirit of St. Louis, but it was an epic feat for the guy, for humanity. You know, first for mankind, first guy to do it, and he flew all the way across the Atlantic Ocean. He was born on May 21st. You got to honor him today. That's why he gets to be the name of our student in Miss Teichmann's class, fourth period. Right, get the easiest 3 points all the time. Okay, I'm also including the section that we're working on. I include that as a title, and I write the problem numbers. Okay, great thing to do when you start as you're copying down what is the actual homework, and when you do that, you're less likely to do ones that you should have skipped or to forget to do ones that you should have done. Okay, I'm also putting the page number in there if you like that, out of the book 441, 442, and the hard part tonight's homework was copying down some of these problems. I haven't even copied down that last one yet. The next page with the table and all those numbers. It wants to do a histogram and stuff. So yeah, follow along, and hopefully I can make this somewhat difficult looking homework a little bit easier for you. All right. Okay. So the first one we have was called nets. You heard me say before that when they make a cardboard box, it doesn't come out 3D. They make it out of flat cardboard. These rolls of cardboard, and then they etch lines on it, and they have a giant stamp that'll just sort of cut through that cardboard, and then they fold things up. Okay, and the first question is these set of questions. They want you to look at these and say, okay, which one of these will actually fold up into a prism? Okay, and which ones won't, and why not? Okay, so if this were a rectangular prism, it looks like I have 1, 2, 3, 4, 5, 6 squares. It would be a special kind of rectangular prism. What would that be called? Hopefully you knew. That would be a cube, right? And just to help you out a little bit there, you can now maybe see better that it's a cube, right? I made a die out of it. Okay, so that would make a cube, special kind. So you're saying yes, that would be a cube on that first one. Okay, now this other one, let's pretend this is the bottom. If I fold that side up, this side up, and this side up, it looks like I could make a triangular prism, right? Then fold that flap across the top. Pretend that's the bottom, that's the top. And each of these from this triangle folds straight up. And then that top piece. Okay? Now, if I fold this side up and this side up and this side up and this side up and this side up, it looks like I could make the start of a pentagonal prism, but it looks like it's missing a top. This would be an open box with no top, huh? Okay, so we're going to say yes on this one. And let's call that a triangular prism. And remember, prisms the same top and bottom. So we're going to say that is the same. Even though they're kind of mirrored, it's because you're going to fold that down once you fold this up. Okay, we're going to say no because there's no top after you fold the sides up. Okay, and I'm going to give you a hint on this last one. Okay, rectangular prisms have 6 sides. This has 1, 2, 3, 4, 5, 6. Okay, but we're going to say no. See if you can figure out why this one doesn't work. Okay, it takes a little bit of visualizing. Some people are really good at this. It's easy. Some people, you really have to think about it. Okay, but take your time and imagine this. If you have to, copy this down on a piece of paper. Okay, cut out the outside and then fold on those lines and see what happens. All right. Now on the 925, they want you to get the surface area of this. Okay, and this is weird because it's got like this L happening. Okay, so I'm going to get the area of this top. 1, 2, 3, 4, 5. I know the bottom is going to be the same, right? Okay, now I'm going to do that back side, right? Okay, and that's going to be 2 tall and 4 wide. So that's going to be 8. Now let's do that left side. And that's 2 tall and 2 wide. Okay. So that's 4. So I have the top, the bottom, and that backside and that backside. Now, what else can we see here? We can see all the other squares. Okay? So I want you to finish that and then add them up. Okay? Well, I think that'll give you enough of a hint on that. Okay? We haven't done everything I colored red so far, but we've done everything we can't see along with that top. Okay, so I left you with the easy part. All right, 9-26. 2 mechanics can assemble 10 bikes in 8 hours. 10 bikes in 8 hours. A, how many bikes could one mechanic assemble in 8 hours? Okay, so he's working the same 8 hours as him and his buddy, and him and his buddy total had 10 bikes. So if they worked the same amount, he should have got half of those for him and half of them for the other mechanic. Okay, right? So we're going to say one mechanic equals 5 bikes in 8 hours. Okay. The next part, it says, use what you know you've determined and write a unit rate for one bicycle mechanic to assemble bikes. So this is one mechanic doing 5 bikes in 8 hours. Okay. Now, do we want to find out how many hours per bike or how many bikes per hour? Okay, a lot of times I like to have the hours on the bottom, but we could do it both ways. Since there's more hours in our bikes, it takes more than an hour to do a bike. I'm writing 8 hours per 5 bikes. And what happens when you divide 5 into 8? Well, it goes one time. And then I get this remainder. And when I get a remainder, I can add a decimal, bring it up, and add a 0, bring it down. And 5 goes into 30 6 times. Perfect fit. So it looks like it's 1.6 hours per bike is how long it takes a mechanic. 1.6 hours per bike. What if I wanted to find out how many bikes per hour? Well, if I did that, I would have the bikes on top, hours on the bottom. The bikes is 5, the hours is 8. Okay, 5 bikes for 8 hours. And if I want a unit rate, now I'm dividing the 8 into the 5. But it won't fit. Add a 0, right? So 8 goes into 50 6 times. That is 48. When I get a remainder, I'm going to add a 0. 8 goes into 22 times. 2 times 8 is 16. I'm going to add one more 0. And 8 goes into 40. Perfect fit. So if I want bikes per hour, it's 0.625 bikes per 1 hour. Okay? All right. On C, it says write an equation that relates the rate, bikes, and time needed for one mechanic. Okay, let T represent the time and B represent the bikes assembled. Okay, so if I, and I think since that's going to be time, I want to use this where I have hours on the bottom, the bikes per hour. Okay, so we're saying the bikes assembled equals the amount of time it takes times, and since it's 0.625 per hour, we're going to put 0.625. Okay, and again, because that is bikes per hour, then time, I'm going to have time and hours here on the top, time on the bottom. They cancel each other out. I get so many bikes, okay, depending on that number. All right, so that's the equation we're going to put down there. And D, use your equation to find out how long it would take one mechanic to assemble 25 bikes. So now I'm going to plug in, that's the number of bikes, 25 equals, we don't know how much time yet, times 0.625. Now, how do we solve this? Well, remember, I'm going to rewrite this. T times 0.625, leave myself a space, equals 25. How do I get the T by itself down here? I have to get rid of everything else. How do I get rid of it? Times 0.625 divided by 0.625. But I can't do that. My equation will be out of balance unless I do the same thing to the other side. So these cancel out. All that's left over here is the time, and that's going to equal 25 divided by 0.625. Now, I'm going to warn you right now, do not divide with a decimal outside the box. The math police will come and get you, okay? But you need to complete that problem, 25 divided by 625 thousandths, to get the answer, okay? I got you pretty far. I know you still have a tough division problem left, but you can do that last part. All right, easiest part of tonight's homework are these distributive property problems. Remember, when they're like this, you have a number or something outside the parentheses, you just have to make sure that you multiply it by each thing inside the parentheses. So in that case, I'm doing 6 times 2 minus 6 times 3y. A lot of people do 6 times 2 minus 3y. They forgot to do the minus 6 times 3y. Same thing here. This isn't 2x times x plus 3. It's 2x times x plus 2x times 3. Okay? So 6 times 2 minus 6 times 3y. You figured out what this is. 2x times x plus 2x times 3. You figure out what those last parts are. Now, these next two, you're kind of working backwards. It's kind of like factoring, and it's a lot like simplifying a fraction. You're looking for something that goes into each term. What goes into 10y and goes into 15? Hopefully you figured out 5, 10, 15, 20, right? 5 goes into both those. So you're going to take a 5 out of 10y. 5 times what is 10y, and write that there. And you're going to say 5 times what is 15, and write that there. Okay? 5 goes into 10y how many times? 5 goes into 15 how many times? Okay? Same idea here. We're looking for something that goes into 2x and 4xy. Well, what do you think? Think about it. Yeah, 2 goes into both. Yeah, x goes into both. So both the 2 and the x. So I'm going to 2x here. 2x times what is 2x? That goes there. Huh? Yeah, I said it again. 2x times what equals 2x? And then 2x times what equals 4xy. See if you can figure out those missing numbers. Okay? Now, this last problem, talking about the Tigers and Panthers, and they're in the same league in basketball. The points they scored in each game are shown in the table below. Make a histogram for each team. Each bin should have an interval of 10 points, 20 to 30, 30 to 40, etc. Okay? So first thing I'm going to do is I'm going to make a new table to tally the points. Okay? And I'm going to say, let's go ahead and put this problem here, 928. And I'm going to pause while I make that table so this tape isn't so scary long for people who haven't already started, okay? Okay, I got my table there. And now I'm going to just put tally marks. I got 0 to 10, 10 to 20, 20 to 30, 30 to 40, right? All the way up to 70. And I probably could have dropped these first two. It looks like neither team had any point totals for any games where they had between 0 and 10 points or 10 and 20. The smallest amount scored looks like the Panthers had 23 on their last game. And looks like the Tigers had 25 on that one game. Okay. All right. So now I'm just do tally marks. Let's do Tigers first. 46. Where am I going to put it? Between the 40 and the 50. Boom. 62 over here. 51. 57, 45, 54, 61, 25, 50, and I'm going 50 just to here, right? So I'm including the 50 on the right side of that. 66, 63, and 68. Okay, and I just want to double check. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I got 5. Remember, you tie that 5 plus 4 more is 9, 10, 11, 12. Good. Now, Panthers 54, 61, 74, 78, 52, 57, 69, 48, 28, 51, 53, and 23. Okay, and again, I got 12, so I got 2, 3, plus 5 is 8, 9, 10, 11, 12. Good. Now, we have that table. We can make histograms. I'm going to set those up real quick. All right, I've set up my graphs. And again, the graphs, you want to label each axis. These are the games on the vertical axis, points on the horizontal axis. I've labeled the teams, so I know which one's which. And I've set up my histogram on the bottom with this. I'm crunching all the numbers between 0 and 20. Remember, we had nothing here. So I don't want to have a bunch of extra columns here. I'm going to have this one extra column just to show you that between 0 and 20, I crunched all the numbers. Okay. Then between 20 and 30, it's going to go here. 30 and 40, right? And I'm going 20, 30, 40, 50, 60, and 70. And since the Panthers had 2 games in 70, I'm going to put an 80 there. Okay? Now I look here and I say between 20 and 30, the Tigers had 1 game. Go up 1. And the Panthers had 2. Between 30 and 40, neither of them had any. So that's going to be a gap in our histogram. That's the only time there is a gap in histograms, is if there's nothing in that bin, nothing in that range, that data range between 30 and 40. Neither team had any games with that many points. All right, the Tigers between 40 and 50 had 2, and the Panthers between 40 and 50 had 1. Now, between 50 and 60, Tigers had 4, Panthers had 5. So 4 for the Tigers. 1, 2, 3, 4, 5 for the Panthers. And between 60 and 70, the Tigers had 5. And the Panthers had 2. Okay. Between 70 and 80, the Tigers didn't have any, and the Panthers had 2. So there's our histograms. Okay, you might color in those, shade them in, but that's what it looks like. Okay. All right, now what they're asking us to do is to find the mean for the Tigers, okay, and the measure of center for the data, okay. Y was finding the mean. Calculate the mean and absolute deviation for each team. I skipped over that. Then we answer C. So B, the mean. Now, first off, just give me a guess. Which team do you think has the highest total when you add up all those numbers? I add up 46, 62, and add them all up. Okay. So I got the Tigers here and the Panthers here. Which do you have? I'm going to let you guys predict. Okay. Then this is pretty cool. 648 for each. I added them all up. Okay. So the mean for each is going to be the same because they both have 12 games and they have a total of 648 points. You divide the 12 into the 648 and you end up with a mean of 54. Okay. So the B is the mean is 54. Now they also wanted us to calculate the absolute deviation. Now the absolute deviation, remember what that is? That's when we figure out how far away from the mean each number is. And 54 minus 46, right? I'm going to do 54 on this, and I'm going to get 8. 62 minus 54, I get 8. 54 minus 51 is 3. 57 minus 54 is 3. 54 minus 45 is 9. And 54 minus 54 is 0. 61 minus 54 is 7. 54 minus 25. Wow. It's almost 30, right? 29. 54 minus 50 is 4. 66 minus 54 is 12. 63 minus 54 is 9. 68 minus 54 is 14. Okay. So I'm getting that. And I believe they want us to do this for both, right? 54 minus 54 is 0. 61, that's going to be 20. That's going to be 24. That's only 2. That's 3. That's 15. That's 6. Oh my, that's 26. That's only 3. That's only 1. And that's 31. Okay, so now we add up. This is how far away from the mean the numbers are. So 16 and 6 is 22, 31, 38. 58, 67, 71, 83, 92, 96, 106 for that one. Here I got 27 and 24 is 51, and 5 is 56, 66, 71, 77, 83, 103, 106, 107, 108, 138 for the Panthers. Okay. And so you can see that the Tigers numbers are closer to the mean than the Panthers numbers. right? They don't deviate as far. They're a more consistent team as far as their points, where the Panthers are kind of all over the place, scoring. Yeah, sure. They scored 23 one time, and yeah, they scored 74 and 78 other times. Those are higher games, but they're all over the place. They deviate from the mean more. Okay, all right. I'm going to let you answer those last two questions and tune back in uh, to get your answers on all of these with tomorrow's video.